Imagine meticulously saving your hard-earned money to buy, like, this premium high-octane fuel for your prized sports car. You drive up to the pump, and then you just pour that expensive fuel directly into the windshield washer fluid tank.
Oh man, that would be completely absurd.
Right. It sounds ridiculous. But according to the source material we're looking at today, if you take a daily multivitamin, there is a 46% chance you are doing the biological equivalent of that exact thing right now.
It's honestly a staggering reality to confront.
Hmm.
Because, you put in the effort, you spend the money, you swallow the pill, and you just assume your body handles the rest. But human biology is, well, it's far less forgiving than we like to think.
Yeah, and if you're listening to this, you're probably someone who genuinely cares about your health. You likely invest time and resources into feeling better, performing better, and living longer. You probably have a cabinet in your kitchen right now with at least a few bottles of vitamins or supplements, but then you inevitably run into that cynical friend or you stumble across some article online that hits you with the classic critique. You know the one.
Oh, I know exactly what you're talking about. The whole supplements just give you expensive pee argument.
Yes, you're just buying expensive pee. It is incredibly frustrating to hear. It feels like this wet blanket on your entire health journey. And it stings because deep down you kind of wonder if they might actually be onto something.
Right. Well, we are going to look really closely at that critique today. Because according to our sources, those skeptics are not entirely wrong.
In fact, they're spot on regarding a vast majority of the products lining the pharmacy shelves. And it's that uncomfortable truth that makes the modern supplement industry such a wildly misunderstood landscape. I mean, the gap between what we think we are putting into our bodies and what our cells are actually receiving is massive.
Huge. It's a fundamental disconnect.
Exactly.
Yeah.
Which is why our mission today is singular. We are diving into a fascinating excerpt from The Ultimate Human Show, specifically episode 252, which features human biologist Gary Brecka.
A great one.
It really is. And we are going to decode the intricate, often frustrating science of bioavailability. We're going to figure out why the supplement industry has been getting it fundamentally wrong for decades.
And more importantly, how your own unique individual biochemistry and even your DNA are the true dictators of whether a pill actually works.
Or whether it just goes on a very expensive, very brief, watery log ride straight through your digestive tract. Okay, let's unpack this. What exactly is bioavailability at a cellular level, and why is it the skeleton key to understanding the entire supplement aisle?
So, bioavailability, if we strip it down to its most rigid scientific definition, is the percentage of a substance that actually enters your systemic blood circulation and becomes actively available for your body's cells to use.
Okay, so it's not just what you put in your mouth.
Exactly. The fundamental mistake people make is believing that swallowing something equates to absorbing something.
Right.
I mean, the human digestive tract is essentially this highly secure, incredibly hostile biological gauntlet. When you take a pill, it has to survive the acidic bath of your stomach.
Which is no small feat.
Right. And then navigate the complex enzymatic environment of your intestines, and then successfully cross over the intestinal wall into your bloodstream. And even then, it has to survive the liver's first-pass metabolism before it ever reaches the systemic circulation where your cells can actually grab it.
That's a lot of hurdles. So let's put some real-world math to this because it really highlights the deception, or I guess at least the deception by omission, on the part of the manufacturers.
Let's do it.
Let's say you buy a bottle of something off the shelf.
Mm-hmm.
The front label has these beautiful, bold, shiny letters promising 100 milligrams of pure nutrient X. You take that capsule, completely assuming your body is now fortified with 100 milligrams of whatever that is.
A fair assumption for most consumers.
Right, but if the bioavailability of that specific chemical compound is only, say, 10%, your body is only getting 10 milligrams.
Precisely. The remaining 90 milligrams are biologically useless to you. They never make it past the bouncers at the door.
The bouncers. I like that.
Yeah, I mean, your liver filters them out, your kidneys process them, and they are ultimately eliminated as waste. That right there is the literal origin of the expensive urine critique. You paid premium retail prices for 100 milligrams, but you just flushed 90 of them down the drain.
Wait, so it's like buying a VIP ticket to a concert, But the ticket is printed in a language the stadium security guard cannot read.
Oh, that's a perfect way to put it.
Like, you paid for the music, you traveled all the way to the venue, you were standing right at the gate with the ticket in your hand, but you are stuck outside the stadium. The music is happening, the band is playing, but you are not experiencing it. Access denied.
That is exactly the dynamic. You have the raw material, but you lack the biological clearance. And to understand why this happens so frequently, you really have to look at the underlying motivations of the commercial supplement industry.
Right, like, why on earth would they sell you a ticket printed in the wrong language?
Exactly. It almost always comes down to two primary drivers: manufacturing cost and shelf stability. The industry is highly unregulated in many aspects, and the primary goal of mass market manufacturing is maximizing profit margin.
Which makes sense from a business standpoint, I guess.
Sure, but producing a chemically active, highly bioavailable, biologically compatible compound is incredibly expensive, and those compounds are often quite fragile.
Fragile in what way?
Well, they might degrade in the heat of a shipping container, or they might clump up and spoil if left on a warehouse shelf for a year.
Ah, I see. So the manufacturers prioritize the rock-solid, indestructible, dirt-cheap version of the nutrient over the delicate, biologically compatible one.
Exactly right. They choose chemical structures that can sit in a plastic bottle under fluorescent pharmacy lights for 3 years without degrading. But here is the critical disconnect. The human body is not a pharmacy shelf.
No, it is definitely not.
Our cells have very specific receptor sites and highly specialized transport mechanisms designed to pull nutrients across the cell membrane. It operates completely on a lock and key mechanism.
Okay, a lock and key.
Right. So if a supplement is structured in a bulky, cheap chemical shape that does not fit those intricate cellular locks, it literally does not matter how many milligrams of it you swallow.
You can swallow the whole bottle, but if the key is the wrong shape, the door stays permanently closed.
Yes, exactly.
And the tragedy is that most people are just reading the front label, the marketing claims, the flashy promises. They are completely unaware that the tiny, unpronounceable form of the ingredient listed in the microscopic print on the back label entirely dictates whether that supplement will be effective.
And it is not a subtle difference either. We are not talking about a 5% difference in optimization.
Yeah.
It is the difference between a potent biological intervention and a complete waste of time and money.
That's wild.
Yeah. To truly grasp how the physical properties of a compound dictate your biological outcomes, we have to look at one of the most widely consumed popular supplements on the planet.
Right, which takes us out of the theoretical and into the physical reality of our guts. Let's look at what the source material brings up regarding creatine.
Oh, creatine, the classic.
Right. For anyone who has ever set foot in a gym, played a high school sport, or even just looked into muscle recovery and energy production, creatine is basically the holy grail.
It is one of the most researched, heavily validated supplements in the history of sports nutrition.
Exactly. But the source points out a massive, purely physical bottleneck with the most common version of it, which is creatine monohydrate.
Yeah, creatine monohydrate is absolutely everywhere. It has been the industry standard for decades. It's incredibly cheap to produce, and theoretically at a cellular level, it works exceptionally well to produce ATP, which is your body's base unit of cellular energy.
Okay, so what's the problem?
Well, it has a glaring physical flaw: its solubility. Simply put, it completely resists dissolving in water.
Oh, man. Anyone who has ever tried to mix it in a rush before a workout knows exactly what you are talking about.
Right? You shake it and shake it.
You put a scoop in a shaker cup, you shake it vigorously for a minute straight, you drink the water, and at the very bottom of the cup is this thick, gritty, sandy residue that coats your teeth.
Exactly. That grit you are feeling is the physical, visual proof of poor bioavailability. The source notes that you need roughly 500 milliliters of water.
Wait, 500 milliliters?
Yeah, that is half a liter, or nearly 17 ounces, just to properly dissolve a single standard serving of creatine monohydrate. Because it resists dissolving so stubbornly, a massive amount of it simply never breaks down in the stomach.
So if it doesn't break down in the stomach, it just passes straight into the intestines completely intact.
That's exactly what happens.
And this is where that infamous creatine bloat comes from, right? Because you essentially have sand sitting in your digestive tract.
That is exactly the mechanism. It sits in your intestinal tract as an undissolved solid. And because creatine is highly osmotic, meaning it actively attracts water, that undissolved powder draws massive amounts of water out of your body's surrounding tissues.
Into the intestines.
Yes, into the intestines in a desperate physiological attempt to break itself down. You end up pooling water in your gut, which leads to gastrointestinal distress, cramping, severe bloating, and discomfort.
So you are carrying around excessive water weight without necessarily getting the actual creatine compound into your muscle cells where it is needed.
Precisely.
Wait, I have to pause right there. If creatine monohydrate requires a veritable swimming pool of water just to break down a single 5-gram scoop, isn't it actively fighting the body's natural digestive process?
Yes, it is.
Like, we are forcing our stomach and intestines to do heavy, stressful mechanical lifting that the manufacturer should have already done in the laboratory.
What's fascinating here is that you have hit on the exact philosophical flaw of modern supplementation. You are creating physiological stress in order to absorb a compound that is theoretically meant to alleviate physical stress and improve recovery.
It is a total biological paradox.
It really is. Now, to be fair to the decades of science behind it, if you drink enough water and endure the bloating, creatine monohydrate does eventually saturate the muscles. It does work.
But at what cost?
Right. The sheer physiological tax it demands from your gut is entirely unnecessary.
So what is the alternative? Did the source material offer a way around this, or are we just doomed to choose between intestinal cramping and missing out on muscle recovery?
Oh, there's definitely an alternative. The alternative highlighted in the source is a completely different chemical structure called creatine hydrochloride, commonly referred to as creatine HCl.
HCl, okay.
By taking the base creatine molecule and chemically attaching a hydrochloride group to it, the manufacturers fundamentally alter how the substance interacts with liquid. It becomes roughly 41 times more water-soluble than standard creatine monohydrate.
41 times. That is not just a marginal upgrade. That is an entirely different universe of absorption.
It is a profound shift. And because the solubility is exponentially higher, it achieves vastly superior intestinal permeability.
Meaning it actually gets through the wall.
Exactly. It does not sit in the gut like an osmotic sponge pulling water from your tissues. It dissolves rapidly upon contact with stomach fluid and passes smoothly and efficiently across the intestinal barrier right into the bloodstream.
The source material actually highlighted a specific study from the journal Food and Nutrition Sciences that put this exact comparison to the test, right? They ran a head-to-head trial.
They did. They took a group of recreational weightlifters and split them up, comparing the monohydrate form against the HCl form.
And what happened?
The results perfectly mirrored the biochemistry we are discussing. Only the group taking the highly soluble creatine HCl saw significant improvements in actual body composition, meaning they actively reduced their body fat percentage and increased their fat-free muscle mass.
And the monohydrate group, did they see those same structural changes?
No, they did not see those structural improvements in body composition. What they primarily experienced was marked water retention and potential weight gain.
Just from the water.
Yeah, they were holding on to the sheer volume of liquid their bodies were forced to retain just to process the poorly soluble supplement.
It is the ultimate example of why simply saying creatine is a complete myth. The exact same foundational nutrient yields drastically different biological outcomes purely based on the chemical delivery system.
Absolutely.
It is incredible. But we just saw how a physical barrier like poor solubility in the gut completely breaks absorption. However, this biological lottery doesn't just stop at physical digestion, does it? Because the source points out an even more intimidating barrier.
That's right. The conversation shifts here from simple gastrointestinal mechanics into the far more complex realm of genetic expression.
Genetics. Now we're getting deep.
Yeah, it is one thing for a supplement to be poorly soluble in water. You can sometimes brute force your way past that by drinking more water. But it is an entirely different, insurmountable problem when your body physically lacks the genetic software required to process a nutrient.
Which brings us back to that 46% statistic from the very beginning. We need to talk about the B vitamins, and specifically, the massive difference between folic acid and methylfolate.
This is a huge one.
For some context, if you go to your pantry right now and look at almost any over-the-counter multivitamin, any prenatal vitamin, or even a box of standard breakfast cereal or a loaf of commercial bread, you will see the words folic acid proudly listed on the label.
Folic acid is truly the darling of the processed food and cheap supplement industries. It is incredibly cheap to synthesize in a lab. It is phenomenally stable on a shelf, basically never goes bad. And it has actually been mandated by the government as an additive in fortified grains for decades to prevent neural tube defects in pregnancies.
Sounds great on paper.
On paper, sure. But there is a massive structural biochemical problem. Folic acid is entirely synthetic. It does not exist anywhere in the natural world.
Wow. And because it is completely synthetic, the human body has no idea what to do with it directly.
Exactly.
It goes back to that analogy of the sports car. The car needs fuel, but it cannot run on crude oil. It needs highly refined gasoline. In the exact same way, your body cannot use folic acid. It has to take that synthetic raw material, process it, and convert it into the active, refined, usable form, which is called methylfolate, or sometimes written as 5-MTHF.
And that biological refinement process is absolutely not guaranteed. It requires a highly specific, complex biological machine, an enzyme.
Okay, an enzyme.
Right. That conversion enzyme is controlled by a specific gene in your DNA called the MTHFR gene, which stands for methylene tetrahydrofolate reductase.
MTHFR. Got it.
Think of the MTHFR gene as the critical foreman on a cellular construction site. His sole responsibility is to take the raw, synthetic folic acid delivered by the trucks and meticulously refine it into the active methylfolate that your cells could actually burn for fuel.
But here's the data point from the source material that absolutely blew my mind. It is a statistic that should honestly be printed in bold red letters on every single multivitamin bottle in the country. Roughly 46% of the population has an MTHFR gene mutation that significantly impairs, or in some severe cases completely blocks, this specific conversion process.
It's astounding.
46%.
Almost half of the entire human population. If you possess this genetic variant, your cellular foreman is either working incredibly slowly, completely on strike, or simply not showing up to the job site at all.
So the synthetic material arrives, but the machinery to process it is broken?
Exactly.
So let's play out the consequences of this. What actually happens to the 46% of people who diligently wake up every single morning, eat their bowl of fortified cereal, and take their daily multivitamin packed to the brim with synthetic folic acid?
It creates a compounding biological disaster over time. The folic acid doesn't just passively not work and harmlessly exit the body through the urine. Because it cannot be converted by the broken enzyme, it physically backs up and builds up in your bloodstream as unmetabolized folic acid.
And what does that do?
This synthetic buildup acts like biological static. First, it can actively mask a severe vitamin B12 deficiency, making your routine blood work look completely normal while your cells are secretly starving.
Oh, wow.
But far more critically, this backlog severely interferes with your body's methylation pathways.
Okay, we need to pause and explore that because methylation pathways sounds like heavy, intimidating biochemistry jargon. I know it involves single carbon atoms and hydrogen atoms, but how does this actually function in a way we can picture?
Think of methylation as the body's master switchboard. It is arguably one of the most fundamental second-by-second biochemical processes keeping you alive. Your body is like a massive mansion fully wired for electricity, but methylation is the process of millions of tiny hands actually flipping the breaker switches on and off to route power to the right rooms.
Okay, I like that analogy. So what are these switches controlling?
Methylation pathways govern everything. They control how your liver detoxifies environmental chemicals and heavy metals. They control how your DNA actively repairs itself from daily damage. They control how you synthesize vital mood-regulating neurotransmitters like dopamine and serotonin.
So if your master switchboard is jammed up by this massive backlog of synthetic folic acid that your body can't process?
Exactly. If your methylation is blocked, those switches stop flipping. Your body's most basic foundational maintenance systems begin to stutter and fail.
That sounds terrifying.
Toxins accumulate, cellular repair slows down, and mood regulation becomes erratic. You feel brain fog, chronic fatigue, and a host of mysterious systemic issues, all while taking a vitamin you thought was making you healthier.
Here's where it gets really interesting. The solution to this massive genetic roadblock is breathtakingly simple, but it requires you to actively read the tiny print on the back of the label. You can bypass the MTHFR genetic mutation entirely simply by taking a supplement that contains methylfolate instead of folic acid.
That is the beauty of understanding bioavailability. Methylfolate is already active. The refinement has been done for you. You are handing the body the premium refined gasoline directly.
No foreman needed.
Exactly. It literally does not matter if your MTHFR enzyme is broken, mutated, or missing, because the body does not need to use that enzyme at all. The nutrient is instantly recognizable, entirely bioavailable, and immediately deployed to those critical master switchboards to get the methylation pathways running smoothly again.
It is such a profound shift in how we are conditioned to think about nutrition. We blindly assume that if we swallow a vitamin, the body inherently knows what to do with it. But understanding this genetic conversion issue makes me wonder, this genetic lottery can't just be isolated to folate, right?
Not at all.
Because if almost half of us cannot process the standard form of one vitamin, the source points out an incredibly similar illusion happening with our cellular energy production.
You're exactly right. The exact same genetic and biochemical illusion plagues another absolutely crucial nutrient, vitamin B12.
Mm.
And the mechanism of deception here is remarkably, almost frustratingly, similar to the folic acid situation.
Let's look closely at the B12 illusion. Most standard over-the-counter B12 supplements, and certainly the ones given out in cheap generic formulations, use a form called cyanocobalamin, and the name itself actually gives away the game if you look closely.
It does indeed. Cyanocobalamin is a completely synthetic molecule engineered in a laboratory. It is synthesized by taking a cobalamin molecule, which is the core of B12, and chemically attaching it to a cyanide molecule.
Wait, cyanide? Like the poison?
Yes, actual cyanide.
Are you kidding me?
No, but to be absolutely scientifically clear, the trace amounts of cyanide in a standard dose are biologically negligible. Your body can process it. It is not toxic at those microscopic levels. However, its presence highlights just how profoundly unnatural the compound is.
That is still crazy to think about.
It is. Just like synthetic folic acid, the human body cannot use cyanocobalamin directly. In order to get any benefit, your body has to recognize the synthetic structure, aggressively cleave off that cyanide molecule, discard it, and then attach a methyl group to convert it into the active biologically usable form, which is called methylcobalamin.
And just like the MTHFR gene acts as the foreman for folate, this complex conversion of B12 is entirely dependent on your genetics. The source mentions specifically the MTR and MTRR genes.
Right.
If you have variants or mutations in these specific genes, your ability to convert that cheap cyanocobalamin is severely, sometimes entirely, compromised.
Which leads to a terrifying reality for a lot of people. You could be swallowing high-dose neon red B12 capsules every single morning, doing everything perfectly right by the conventional, standard American diet rules of health, and still be functionally, dangerously deficient in B12 at the deepest cellular level.
But wait, I have a question about how this plays out in the real world. Say someone is exhausted, they go to their primary care doctor, complain of chronic fatigue, and the doctor runs a standard blood panel.
A very common scenario.
Right. The doctor might look at the lab results and say, great news, your B12 levels are through the roof. You're completely fine. How is that scientifically possible if they are functionally deficient?
This requires us to understand a crucial, often overlooked difference in diagnostics, the difference between serum B12 and cellular B12.
Okay, break down the difference.
Serum B12 is simply a measurement of the vitamin floating freely in your systemic bloodstream. Cellular B12, however, is the measurement of the vitamin that has actually successfully penetrated the cell membrane and entered the mitochondria, the powerhouse of the cell, where it is actively used as fuel to create energy. Standard blood tests almost exclusively measure serum levels.
Wait, so taking synthetic B12 is essentially creating a massive gridlocked traffic jam of delivery trucks on the highway. The highway is your bloodstream, and it is absolutely packed bumper to bumper with these trucks carrying food.
That's a great visual.
If a news helicopter takes a picture from above, they will report, wow, look at all the food in the city. We have an abundance. But the actual grocery stores, which represent your cells, have completely empty shelves.
Yes.
The delivery trucks are stuck on the highway. They cannot navigate the off-ramps. They cannot unlock the loading dock doors. And the food never actually makes it inside the store where people can use it.
This raises an important question about how we interpret a massive amount of clinical medical studies and how routine blood work can sometimes lead us utterly astray. Many conventional studies vehemently defend the use of cyanocobalamin.
Because of the blood tests.
Exactly. They will point to clinical trials showing that when patients take the synthetic version, their serum B12 levels rise just as sharply and effectively as when they take the active methylcobalamin. Based on that single metric, they declare the cheap synthetic version a total success.
But they are only measuring the traffic jam. They are counting the trucks on the highway, completely ignoring the fact that the grocery store shelves are bare.
Precisely. High serum B12 in the blood does not tell you a single thing about what is actually happening inside the mitochondria. In fact, consistently high blood levels of B12 when you are symptomatic can sometimes be a massive red flag.
Really? A red flag?
Yes, because it can indicate that the synthetic B12 is permanently trapped in the bloodstream entirely unable to convert to the active form due to those genetic polymorphisms we just discussed. It cannot cross the threshold into the cell.
So the blood levels rise exponentially because the nutrient is literally backed up like sewage.
Yeah, backed up, while the mitochondria are simultaneously starving for the energy production catalyst they desperately, urgently need.
It is maddening to think how many people are told they are fine when their cells are starving. But thankfully, the solution is identical to the folate issue. You bypass the broken genetic machinery by taking methylcobalamin.
That's it.
You entirely skip the conversion step. You give the body the exact active pre-cut key that flawlessly unlocks the cellular door.
You know, B vitamins are heavily associated with daylight activities, energy, cellular fuel, cognitive drive, and focus. But this ironclad rule of bioavailability is equally, if not more, crucial when we want the body to do the exact opposite.
Oh, like sleeping.
Right. The rules of absorption apply just as strictly when we need the nervous system to downregulate, rest, and recover.
Which takes us right into the mineral that almost everyone seems to be perpetually deficient in and that everyone seems to be trying to take right before bed, magnesium.
Magnesium, such a vital mineral.
It is. But if you walk into any big box pharmacy or grocery store and grab the cheapest, largest, most widely available bottle of magnesium off the bottom shelf, you are almost certainly holding a bottle of magnesium oxide.
And magnesium oxide is arguably the worst offender in the entire mineral supplement category.
Oh, worse.
Easily. It is dirt cheap for manufacturers to source from the earth, but its bioavailability profile within the human body is absolutely abysmal. The source material highlights studies noting that only about 4% of magnesium oxide is actually absorbed across the intestinal wall into the bloodstream.
4%. Let's go back to our math from the very beginning of the show. If you take a capsule containing 100 milligrams of magnesium oxide, your blood receives a pathetic 4 milligrams.
Yep.
But here's the real kicker. Where do the other 96 milligrams go? With the B vitamins, we learned the synthetic stuff floats in your blood or gets filtered into the urine. But with magnesium oxide, that unabsorbed 96% doesn't just pass through quietly, it sits right there in your intestinal tract.
And this is where the biochemistry gets incredibly uncomfortable. Magnesium is a highly hydrophilic mineral, meaning it aggressively attracts water.
Kind of like the creatine we talked about earlier.
Similar, yeah. So this massive undigested bolus of unabsorbed magnesium oxide sits directly in your bowel, draws in immense amounts of fluid from your delicate intestinal walls, and acts as a literal, powerful osmotic laxative.
This is exactly why magnesium oxide is the primary active ingredient in heavy-duty over-the-counter constipation medication.
Exactly.
It works brilliantly if you are backed up and need to drastically clear out your bowels, but it is an absolute biological disaster for the poor person who bought it, thinking it was going to help them gently wind down and relax after a stressful day.
Imagine the profound physiological contradiction happening inside that person. You are a highly stressed, overworked individual. You are taking a magnesium supplement right before bed, hoping to gently calm your frayed nervous system, soothe your tense, aching muscles, and transition smoothly into a deep, restorative cycle of sleep.
And
Instead, you introduce a compound that chemically forces your lower gastrointestinal tract into emergency overdrive.
Yeah.
You are artificially inducing severe digestive distress and creating massive internal biological stress. Your immune system and your gut are fighting a war to process a heavy laxative while your brain is desperately trying to shut down for the night.
it is completely counterproductive. It is friendly fire on your own nervous system. You are paying money to sabotage your own sleep. So what is the bioavailable alternative that actually does the job it is supposed to do?
Well, if your goal is relaxation, muscle recovery, and sleep, you have to look for a chelated form of the mineral, specifically magnesium glycinate, which is sometimes listed interchangeably as magnesium bisglycinate.
Glycinate, okay.
In this specific formulation, the base magnesium molecule is chemically bound or chelated to glycine. Glycine is an amino acid.
Okay, I want to drill down into that. Why does binding a mineral to an amino acid change the absorption game so drastically in the gut?
Because your intestinal walls have highly efficient, specialized, massive transport pathways designed specifically by evolution to absorb amino acids from the proteins you eat. The body is incredibly good at absorbing amino acids.
So it recognizes the glycine.
Exactly. When the magnesium is tightly bound to the glycine, your body sees the amino acid coming down the digestive tract, recognizes it as valuable protein material, aggressively opens the transport pathway, and pulls the entire molecule, magnesium included, smoothly through the intestinal wall and into the bloodstream.
Oh, that's brilliant.
It literally sneaks the bulky mineral past the strict digestive barrier like a microscopic Trojan horse.
A Trojan horse, I love that.
But the brilliance of this doesn't stop at absorption. Glycine itself is a powerful inhibitory neurotransmitter.
If you'll connect this to the bigger picture, it means the delivery vehicle itself, the glycine, actually has its own therapeutic calming benefit.
Exactly. You are getting a 2-for-1 biological intervention. Glycine naturally promotes relaxation in the brain. It has been shown to lower core body temperature, which is a strict physiological requirement for your brain to initiate deep, slow-wave sleep.
Right, your body has to cool down to sleep deeply.
Yes. So with magnesium glycinate, you completely avoid the gastric distress and the laxative effect because the molecule is fully rapidly absorbed in the small intestine. And once it safely enters the bloodstream, the magnesium can actually go to work doing what you originally bought it for, supporting and activating the parasympathetic nervous system.
The parasympathetic system, the rest and digest mode, the vital counterbalance to the chronic fight or flight mode most of us are stuck in all day.
That's the one.
It allows the skeletal muscles to finally release their tension, the heart rate variability to improve, and genuine high-quality restorative sleep to take over. It is truly astounding how granular and deeply impactful these biochemical tweaks are. A single tiny word printed on the back of a label oxide versus glycinate, cyanocobalamin versus methylcobalamin, is literally the difference between agonizing digestive stress and deep, profound cellular recovery.
It really is.
But looking at all these specific pathways also makes me reflect on the broader ecosystem of human optimization that this source material originates from.
Right. It is incredibly important to contextualize this information. The source material we are pulling from today is an excerpt from human biologist Gary Brecka's broader Ultimate Human platform.
Yeah.
And he is not just operating as some rogue supplement recommender tossing out vitamin names on the internet. He is cultivating a massive, comprehensive VIP community. He conducts monthly live Q&A sessions, hosts exclusive private deep dives for his members, and offers a highly structured, comprehensive educational course called Becoming the Ultimate Human.
Right. The source mentioned that this extensive course is valued at roughly $1,700, though he offers it directly to his VIP members. And what really struck me as I was reading through the source material is that the modules within this high-ticket course are absolutely not just take this pill at 8 a.m., then take that pill at noon.
No, not at all.
He doesn't treat supplements as the foundation. The modules are heavily focused on fundamental lifestyle pillars, sleep architecture, stress mitigation, whole food nutrition, and psychological mindset.
That holistic framework is absolutely vital to understand, because we can sit here and debate the fascinating minutia of molecular solubility, genetic enzyme expression, and amino acid transport pathways all day long. But if the foundational pillars of your house are actively crumbling, the most highly bioavailable, perfectly methylated supplement on Earth will not save you.
That is exactly where I want to push back a little on the whole biohacking culture that has exploded recently.
Right, I know what you mean.
There is such a massive temptation, especially when you learn about cool, cutting-edge concepts like methylation cycles and chelated Trojan horse minerals, to start treating supplements like magic wands.
Oh, for sure.
But if you are grinding away on 4 hours of sleep a night, if you are drowning in chronic, unmanaged psychological stress from your job, if you are eating highly processed garbage out of a drive-through window, and if you are operating with a negative, toxic mindset, taking methylfolate instead of folic acid is like putting a tiny, expensive Band-Aid on a massive, gushing arterial wound. The supplements are a highly precise, beautifully engineered tool, but they are just one tool in a much larger toolkit.
Well, I do believe that fixing a genetic deficiency like an MTHFR mutation can feel like magic for someone who has been suffering for decades. You are ultimately correct. Supplements are designed to supplement a healthy lifestyle. They cannot systematically replace one.
Right.
The Ultimate Human course provides that overarching framework because you cannot out-supplement chronic sleep deprivation or a terrible diet. However, what this deep dive into bioavailability fundamentally proves is that when you do have your lifestyle dialed in and you do reach for that tool, you need to ensure it is actually a functional tool, not a plastic toy.
A plastic toy won't build a house.
No, it won't. True. Optimized health requires an intimate, honest understanding of your individual biology. You have to remove the friction. If your body is already fighting the daily stress of modern life, the absolute last thing you want to do is force it to fight a synthetic vitamin or a poorly soluble mineral just to extract a tiny fraction of a benefit.
So what does this all mean for the listener? How do we take hours of advanced biochemistry, genetic mutations, and cellular transport mechanisms and turn it into something you can actually use right now, today, in your own life to stop wasting your money?
Let's give them the takeaway.
Let's distill this into a hard, fast, highly actionable checklist for your medicine cabinet. If you are listening to this, I challenge you. When you get home, go straight to your kitchen or your bathroom and physically turn your supplement bottles around. Do not look at the flashy front label. Look at the tiny, boring print on the back.
That's where the truth is.
Exactly. First, if your daily multivitamin, your B complex or your prenatal vitamin says folic acid, throw it out or finish it and immediately switch to a specialized form that explicitly says methylfolate or 5-MTHF. Do not let a broken cellular formin stall your master switchboard.
Excellent rule number 1.
Second, if your energy or B12 supplement says cyanocobalamin, remember that completely unnecessary cyanide molecule, switch immediately to methylcobalamin so you can finally get those delivery trucks off the highway and into the grocery store.
Get the food on the shelves.
Yes. Third, if your nighttime sleep, relaxation, or muscle recovery supplement relies on magnesium oxide, you are just buying an extremely expensive laxative. Switch to magnesium glycinate or bisglycinate for true Trojan horse absorption and deep nervous system relaxation.
No more friendly fire on your gut.
And finally, if you are an athlete, a runner, or a gym goer taking standard creatine monohydrate and you constantly feel bloated, heavy with water, or experience stomach cramps, switch to the highly soluble, rapidly absorbed creatine HCl.
Making those 4 simple, precise swaps represents a massive quantum leap in how your body biologically interfaces with the nutrients you are giving it. You are stepping out of a paradigm of generic, mass-produced hope and moving into the realm of precise, biologically aligned intervention.
It's empowering, really.
It is, but as we wrap up this deep dive, I want to leave you with a broader, perhaps more provocative thought to deeply mull over. We spent a lot of time talking about the MTHFR gene mutation and how 46% of the human population physically lacks the genetic machinery to process the most common, legally mandated form of a vital B vitamin.
Almost half the population.
Right. Think about the massive societal implications of that single staggering statistic. It strongly suggests that the entire era of one-size-fits-all nutrition, the comfortable idea that a single generic daily multivitamin formulated in a lab can serve an entire diverse human population, is rapidly coming to a definitive, scientifically validated end.
The end of the generic multivitamin.
I really believe so. I want you to imagine a near future, perhaps only a few short years away, where the process of looking at a supplement label has absolutely nothing to do with reading the manufacturer's marketing claims or checking the milligrams. Instead, the process of buying a vitamin will involve seamlessly cross-referencing the specific chemical ingredients directly with a digital map of your own DNA on your smartphone.
Oh, wow.
We are rapidly entering an age where your unique genetic code, your specific inherited enzyme deficiencies, and the highly individualized makeup of your gut microbiome will dictate exactly which chemical locks need which specific keys.
That is incredible.
The future of health and the absolute end of expensive pee is not about finding the best or most popular supplement on the market. It is about finding the only precise chemical structure that your specific, unique body actually recognizes as real.
It is absolutely wild to think about. We are moving from blind guesswork into true biological precision. The next time you find yourself staring down that overwhelming aisle of shiny plastic bottles at the pharmacy, remember that concert ticket. Don't pay your hard-earned money for a ticket printed in a language your body's security guards can't read. Thank you so much for joining us on this deep dive. Stay curious, question the promises on the front of the bottle, and always, always read your labels closely.